Friends, already we discussed about the intrinsic semiconductor and extrinsic semiconductor. That means the pure semiconductor and in extrinsic semiconductor, N-type semiconductor and P-type semiconductor. In N-type semiconductor, the majority charge carriers are electron, while the minority charge carriers are hole. While in P-type semiconductor, majority charge carriers are hole and minority charge carriers are electron. Now what's happened? Yes, we connect the both P-type and N-type semiconductor with each other. So as a result, the PN junction is formed. That is the most important device in electronics. But the PN junction is not formed directly. Connection of separate P-type and N-type semiconductor. Right? Because as we directly connect the separate P-type and N-type semiconductor, the conduction of electron and hole not take place properly. Due to that reason, how the PN junction is formed. Today we are going to discuss about the PN junction. How the PN junction is developed and due to the formation of the PN junction, what's happened? Today we are going to discuss. Now the question is that explain the PN junction. Okay. Now we take the thin silicon crystal, like as a wafer, very thin silicon crystal. We know that silicon is tetravalent. It has the 4 valence electron. At 0 Kelvin temperature, all these 4 valence electrons are used to form the 4 covalent bond with its 4 neighboring other silicon atom. As the temperature increases, so these covalent bonds are broken and the electron hole pair are formed, and as a result, the conduction of pure semiconductor, that means the intrinsic semiconductor, is take place. Now, in thin crystal of pure silicon or germanium, suppose at one end, the divalent impurity, like as the aluminum, indium or boron, are added. So this end of a silicon crystal is act as the P-type semiconductor. Already we discussed how the P-type semiconductor is formed. Right? Again, when a thin silicon crystal, one end of a thin silicon crystal, we are adding the divalent impurity like as the aluminum, indium or the boron are added. So this end of a silicon crystal act as the P-type semiconductor. While at the other end of the same silicon crystal wafer, we are adding the pentavalent impurities like as arsenic, antimony or phosphorus. So this end of a silicon crystal act as the N-type semiconductor. Like to this manner, that is the pure silicon crystal, thin silicon crystal. Yes, we are adding the divalent impurity atom at this end. So this end is act as the P-type semiconductor. And other end, we are adding the pentavalent impurity atom. So this end is act as a negative, that means the N-type semiconductor. This way, in pure silicon crystal, we develop the PN junction. So in this region, N-type semiconductor, majority charge carriers are electrons. While there is the P-type semiconductor, so here the majority charge carriers are hole. Here is okay. So in N-type region or the N-type semiconductor, majority charge carriers are electron, and this electron diffuse in P-type semiconductor. Now, during the formation of the p-n junction, here the two processes take place. One is the diffusion and second is the drift. So, as a result, in p-n junction, the electric current is formed due to the diffusion process and drift process. How the diffusion and drift take place, we are going to discuss this thing. So, during the formation of p-n junction, in n-type semiconductor, majority charge carriers are electrons. These electrons are diffused in hole of p region. Hole of p region. Okay. Now we discuss in n-type semiconductor. In n-type semiconductor is formed by adding the pentavalent impurity, that means the donor impurity atoms. This impurity atom has the tendency to donate the electron. Therefore, in n region, these are the impurity atoms, has the tendency to donate the one electron. After donating the one electron, it becomes the ionized positive charge. Ionized positive charge. Whatever the electron is donated, this electron is diffused in p region of this junction. Okay. In p region, already the trivalent impurity atoms are present. The trivalent impurity atoms are the acceptor atoms. It has the tendency to accept the electron. So, what are the electrons donated by the pentavalent impurity from n region? These electrons are accepted by the acceptor impurity atom in p region. After receiving accepting the one electron, it becomes the negative ionized charge. This positive and negative ionized charge cannot move. These charges are immobile. Therefore, these positive and negative charges are developed near the junction in respective region. Positive charges near the junction in n region, while the negative charges near the junction in p region are developed. Okay. What is the diffusion of electron from n region to p region? The same diffusion of the hole take place from p region to n region. So as a result, the electric current is formed across the junction, and that is known as the diffusion current. That is known as diffusion current. Due to the diffusion process, these ionized charges are developed on either side of the junction. So this region near the junction is known as depletion region or the depletion layer. The width of a depletion region is in order of 1/10 of 1 micrometer. In p-n junction, the width of a depletion region is in order of 0.5 micrometer. So keep in mind this sentence that is frequently asked in 1 marks objective question in NEET and also the good set. The width of a depletion region is in order of 1/10 of 1 micrometer or approximate 0.5 micrometer. Here is okay. Now what's happened? These ionized charges, positive charges, are developed in n region near the junction, while the negative ionized charge is developed in p region near the junction. Due to the deposition of these charges near the junction, the electric field is formed. The direction of this electric field in depletion region is from positive to negative. That means the n-type semiconductor to the p-type semiconductor. That means the direction of electric field is in this n to p region. And that is known as potential barrier. That is known as potential barrier in p-n junction diagram. Clear this? Okay. So that is the diffusion process, or the diffusion current take place during the formation of the p-n junction. Now, how the drift current is developed? Now, this electric field is established near the junction or at the junction. So, as a result, what's happened? Here, the positive charge. This positive charge attract the electron from the p region. So, as a result, the electrons are now dipped from p to n. During the diffusion process, electrons are diffused from n to p. There is the diffusion process, there is the drift process. First, the diffusion process takes place. As a result, the electric field is established. Due to this developed electric field, the electron from p region dip to the n region. That means the electrons are moving from p to n region under the influence of electric field established in depletion region. The same manner, the minority charge cages are held in n region are also dipped from n to p region. Now keep in mind that drift of this charges only take place due to the electric field established in the region. While for the diffusion, no field required. For drift, the field is required. So due to the drift of electron and hole, under the influence of the external electric field or the electric field established near the junction, so drift current is also formed. Clear this? Initially, the diffusion current is maximum and drift is less because just started the diffusion. At that time till the positive and negative ionized charges are not developed sufficient near the junction. Therefore, the weak electric field is established, and due to that reason, the depth of the charges is very, very less. Only the diffusion current is take place. As the time passes, more and more charges are diffused. So, ionized positive charge and ionized negative charge deposited more. Therefore, the electric field established near the junction is also more intensive. But the intensity of this electric field is going to increase. As a result, the depth is also going to increase. Thus, the diffusion takes place less after some time and the depth takes place more. This process occurs till the both current due to the diffusion and depth becomes the equal. So that is the process of p-n junction formation and also how the p-n junction is formed and current is formed during the p-n junction. That is the theoretical. As our concept about the p-type and n-type semiconductor is clear, so that is very easy, right? And here there is the what's happened during the p-n junction. We must we must be familiar with that. At that time, the p-n junction is very easy topic. Again, we repeat it. Now, when the trivalent impurity, like as the aluminium, indium, or the boron, are added at one end of a thin silicon crystal, the p-type semiconductor, and at other end, pentavalent impurities, like as the arsenic, antimony, or the phosphorus iodide, the n-type semiconductor formed. Right? Thus, the p-n junction is formed like this. This figure is only for understanding how the p-n junction or how we add the trivalent and pentavalent impurity in pure silicon crystal. Okay. Clear this thing? Okay. Now, the two process occurs during the formation of the p-n junction. One is the diffusion and second is the drift. When the p-n junction is formed, at the time the two process. We have to explain these two processes. One is the diffusion and second is the drift take place. Now first we discuss about the diffusion. How the diffusion take place. Now in N-type semiconductor, majority charge carriers are electrons. Thus, the electrons are diffused from N semiconductor to P semiconductor. That means P into P is here. Again, in N-type semiconductor, majority charge carriers are electrons. Therefore, the electrons are diffused from N-type semiconductor to P-type semiconductor. While in P-type semiconductor, majority charge carriers are 1. Therefore, the 1 are diffused from P semiconductor to N semiconductor, that is P12. While in P-type semiconductor, majority charge carriers are 1. So, holes are diffused from P to N semiconductor. Clear this? Okay. Now, this motion of the charge is formed a diffusion current across the junction. Due to the diffusion, electron from N to P and one from P to N, that forms the diffusion current across the junction. Now, during this diffusion process, what's happened? When an electron diffuses from N to P region, it leaves one ionized positive charge in N region. When the one electron are diffused from N to P, at that time this electron leaves the one ionized positive charge in N region. The same way, when the hole are diffused from P to N, it leaves the one ionized negative charge in P region. So this paragraph is this: when an electron diffuses from N to P region, it leaves one ionized positive charge in N region, and during diffusion of hole from P to N region, it leaves one ionized negative charge in P region. These ionized charges can't move. That means these charges are stationary. Thus, during the diffusion process, the positive space charge region on inside of the junction and negative space charge region on P side of the junction are developed. So there is the positive space charge region in inside near the junction, and there is the negative space charge region in P side of the junction are developed. The space charge region on either side of the junction is known as depletion region or depletion layer. Right? The thickness of depletion region is of the order of 1/10 of 1 micrometer. 1/10 of 1 micrometer, approximate 0.5 micrometer in PN junction. In PN junction. What is the width of the depletion layer or the depletion region in PN junction? That is the 1/10 of 1 micrometer or approximate the 0.5 micrometer. Due to positive charge on N region and negative charge on P region, the electric field is established or developed in the direction from N to P. This electric field is developed in the direction from N to P. Clear this? Okay. Now we discuss about the drift. Now the electric field is established across the junction in the direction from N region to P region. So what's happened due to the development of the electric field near the junction? So there is the PN junction, there is the N-type semiconductor, there is P-type semiconductor. In N-type semiconductor, the electrons are the majority charge carrier, while the holes are the minority charge carrier. During the diffusion process, inside of the junction, here the positive charges are developed. Due to the diffusion of the electron from N to P, Okay. Now in P-type semiconductor, majority charge carriers are hole, minority charge carriers are electron. And due to the diffusion of the hole from P to N, near the junction in P region, the ionized negative charges are developed. Diffusion takes place of electron from N to P, and diffusion of the hole takes place from P to N. So as a result, the diffusion current is take place, right? And the ionized positive charge in N region near the junction, while the ionized negative charge in P region near the junction are developed. Due to these space charges are developed in the region. Here the electric field is established in the direction from positive to negative, that means the N region to P region. This electric field is established. Okay. Now due to this electric field, during the diffusion process, the more and more positive charges are accumulated near the junction in N region, and the negative charges in P region near the junction are deposited. Therefore, the electric field becomes the more strong, but the strength of the electric field is increases. When the electric field is sufficient, becomes the strong, so it pulls down the electron from the hole, and these holes are now moving from P to N region. This pull down the electron from P to N region. Therefore, the electron now moving from P region to N region, and holes are moving from N to P region. That means the depth of the electron from P to N and hole from N to P takes place. So as a result, the depth current is generated or the format. So a depth current is formed after the development of or the establishment of the electric field. Therefore, initially, only due to the diffusion process, diffusion current is more and depth current is less. As the diffusion process is continued, so the intensity of the strength of the electric field is increases. As a result, the depth takes place, and then the depth current is also increases. This process is take place until the both current becomes equal. When the both current, diffusion current and depth current becomes equal, so in this situation, the PN junction is in equilibrium. The PN junction is in equilibrium. Therefore, in equilibrium of PN junction, there is the no net current. Current flowing becomes zero. Clear this? Okay. Now we discuss like this. Due to this electric field is this in the direction from N to P. What's happened? The electron on P side of the junction move to the N side, and hole on N side of the junction move to P side. Electron minority charge carrier in P region. Due to this electric field, these minority charge carriers are moving from P to N region. The same way, the minority charge carriers are hole in N region are moving from N to P. The minority charge carriers hole, due to this electric field established in the junction, the hole are moving from P to N to P side. The motion of the charge carrier due to the electric field is known as the drift. Right? Initially, the diffusion current is more and drift current is less. Because initially the diffusion process just started, at that time the deposition of the charges would take place, therefore the electric field induced is almost zero. Therefore, drift is also zero. As the diffusion process continues, the electric field increases, and hence the depth current is also increases. This process continues until the diffusion current and depth current becomes the equal. The process of the diffusion and depth is continuous till the both current becomes the equal. When the both current becomes the equal, at that time the diffusion and depth is stopped. Thus, a PN junction is formed. It has the two connection terminal. One is this end and that is the other end. Therefore, that is known as the PN junction diode. That is known as PN junction diode. In equilibrium of PN junction, there is no net current. Equilibrium position, that means when the depth current and diffusion current and depth current becomes the equal. At that time, there is no difference. Therefore, the net current flowing in the PN junction is zero. So that is the equilibrium condition of the PN junction. Clear this? This figure is only for your understanding. It is not necessary to do. Already we have drawn in first part.